Greetings, I'm Dev the Developer. Last lesson we covered while loops and do while loops. This time we're looking at two more loop types, the for loop and the for each loop. The for loop packages the counter, setup, condition, and increment all in one line. The for each loop gives you each item in a collection without any index management. Both are things that you'll use constantly. Let's start with the for loop. You've seen while loops where you declare a counter before the loop, check in the condition, and update it at the end of the body. A for loop puts all three of those pieces in one place. There are three parts inside those parentheses, each separated by semicolons. This first part is the initializer, the int I equals 1. This runs exactly once before the loop starts. It declares the counter variable and gives it a starting value. The second part is the condition, I less than or equal to 10. This is checked before every iteration. When it's false, the loop ends, same as the while loop condition. The third part is the iterator. This runs after each iteration. It's how the counter advances. So the loop runs, prints I, increments I, checks the condition, and repeats. When I hits 11, the condition is false and we exit. One thing worth knowing, I is a convention. It stands for index or iteration, and you'll see it in essentially every C# code base. You can use any name you want, but I is what other developers expect to see. The three parts of a for loop aren't locked in any particular direction. You can count in any direction you want by adjusting all three pieces. Start at 5, run while I is greater than or equal to 1, and decrement instead of increment. That's all it takes. The structure is the same. The direction just flips. Let's look at an example where the loop body does something more than just prints a counter. A classic use case is accumulating a total. We declare sum outside of the loop because it needs to persist across the iterations. If we declared it inside the loop, it would reset to 0 every time. The plus equal operator is shorthand for sum equals sum plus I. By the time the loop finishes, sum holds the total of all 10 values. Now, for each. This one is built for a different job. Where for is great when you're counting through a range, for each is great when you have a collection of items and you just want to process each one. The syntax is for each, then parentheses, a type, a variable name, in, and then the collection. A string is simply a collection of characters. For each hands us each character one at a time. We don't have to track any index. We just say, give me each character in Word, and the loop handles the rest. The same pattern works for any collection. We'll work with arrays and lists throughout the course, and for each will be a natural fit for both. There's a useful tool worth knowing about, Enumerable.Range. It generates a sequence of integers. You give it a start value and a count, and it produces as many consecutive numbers beginning at the start. The first argument is the starting value. The second is how many numbers to produce. So range 1, 5 gives you 1 through 5. This is a concise way to iterate over a range of numbers without writing the full for loop header. Notice the second argument is a count, not an end value. Range 1, 5 ends at 5, but range 3, 5 will give you 3 through 7. That's the thing to double check when you first use it. Both for and for each support two keywords you already know from while loops: break and continue. We can look at them in context and see break stops the loop immediately and jumps to the code after it. It's useful when you're searching and you found what you need. Once I hits 2, the condition is true. We print the result and break out of the loop. No point running through the remaining 18 iterations. Continue is different. It doesn't stop the loop, it skips the rest of the current iteration and goes back to the condition check. When I is odd, we hit continue and the loop immediately moves to the next iteration. The console write line at the bottom never runs for odd values, only even numbers make it through. One thing to be careful about with for each: don't modify the collection you're iterating over while the loop is running. Adding or removing items from a list during a for each will cause an exception at runtime. We'll cover lists later in the course, but it's worth planting that flag now. So, when do you reach for versus for each? Use for each when you just need each item and you don't care about its position. It reads cleanly and there's no index to manage. Use for when you need an index. For example, when you want to print item 1, item 2, you need that counter. Or when you're counting through a range of numbers and the number itself matters to the computation. Both loops get the job done. The choice is usually about which one makes the code more readable for whoever comes after you. For and for each cover most of the looping you will do in practice. You've seen them handle ranges, collections, breaking early, and skipping items. Write some loops, break them on purpose, and fix them. That's generally the fastest way to get comfortable with these. Don't just watch it, do it.